emissions to create near-term climate mitigation. Because of methane's high contribution to global heating over relatively short atmospheric lifetimes, cutting emissions today will achieve a reduction in global heating that is concentrated over the next 10 years or so. And especially in light of recent setbacks on efforts to cut CO2 emissions, especially at the federal level in the United States, it's now more important than ever to aggressively cut superpollutants. In fact, in some ways, I think methane control may be the most important thing that any of us on this webinar is working on right now. But effective control of methane emissions has historically been made more difficult by the relatively limited information available about where it's emitted, when it's emitted, from what sources. Methane emissions estimates have typically used what they call bottom-up methods, in which an observed level of some emissions producing activity, say the volume of oil produced at a facility or the number of cows at a pasture, is multiplied by an emissions factor that's derived from prior research to yield an estimate of total methane emissions. Bottom-up estimates are useful. They certainly have their place, but they are really imperfect, and they're not as helpful as they might be. In most cases, for example, they seriously underestimate actual emissions. They rely on emissions factors that are in many cases old or unrepresentative. They neglect variation over time, location, and activity, and they really aren't well suited to support effective, responsive monitoring and control of methane. Direct observation of methane emissions is better, but until recently, direct observation required expensive, limited duration field campaigns with airborne or ground-based instruments, which is where satellites come in. New satellite-borne instruments are transforming the ability to observe methane directly. Satellite instruments now enable more precise, complete, and reliable observations of methane emissions from space. In turn, scientists can turn observations of methane in the atmosphere into useful and near real-time estimates of emissions and emissions rates at low cost, at scales ranging from individual projects and point sources to jurisdictional areas and even the globe. As you'll hear, satellites can now see and report on methane from individual wells, from landfill sites, from coal mines, and from agricultural sources. They can help create much more accurate estimates of jurisdiction-wide emissions inventories. And data from satellites is increasingly available on public portals and in other ways. Of course, I will pause here and note that satellites are not perfect, as the recent loss of one of the most promising new satellites, MethaneSat, illustrates. But they are a vast improvement over older methods with real promise for transforming certain kinds of methane control. So we decided to undertake our joint project with Berkeley because these developments are really exciting, but they also raise a lot of new questions, especially in the law and policy realm. From conversations with policymakers around the world, it became clear very quickly that folks are both excited by these new satellites, but also need a lot more information about what these satellites are, how they work, and importantly, how policymakers can use these new data to improve methane control. So the paper that we worked on jointly and are publishing is one step toward answering some of these questions. I will note that more work is needed, and we look forward to continuing to push these questions forward in partnership with Berkeley and others. UCLA, for example, is publishing a second paper soon with some additional detail on how satellites work. And I know that both UCLA and Berkeley are both committed to providing tools for policymakers in an ongoing way to help fulfill the promise of these satellites on the ground in real-world settings. And with that, I'm happy to turn it back to Ted and my fellow panelists to dive into the report in more detail. Many thanks.
Great. Thank you so much, Cara. Thanks for that excellent intro. We're going to turn it over to Fran Reuland of Stanford University in just a moment here, if we can pull the slides back up. And as we do so, I wanted to note, Cara, just how a testament to the newness of the work and the importance of guidance here, in that your description of bottom-up versus satellite approaches is completely different from the one we were giving not 3 years ago when we started our methane work here at CLEE. The field has shifted so tremendously in such a short period of time. the relevance of this kind of explanatory work is just is so evident. So with that, Fran, take it over.
Great, thanks, Ted. And thank you, Cara. As mentioned, my name is Fran. I'm a graduate student at Stanford, and I had the awesome pleasure of getting to work with the folks at CLEE and Emmett as part of this report. I'm going to be talking just a couple minutes here about the methane technology satellite ecosystem. And I like to, I always borrow this graphic from Daniel Jacobs' group at Harvard, because I think it does such a nice job of visually showing both the quantity and to some extent the variety of different satellite instruments that are currently available in orbit making methane observations from space. The missions are unique in several ways, one being that they span government research agencies as the operator and launcher, all the way to commercial instruments, as well as nonprofit and hybrid private nonprofit partnerships as well, namely the Carbon Mapper satellite. And one, I think, useful characterization or categorization of these instruments is that of being either a point source imager or an area flux mapper. And the main difference being that point source imagers were really designed and built to identify and quantify emissions from specific sources. So for example, a methane leak coming from a facility, and we have an example of that in the next slide. And area mappers are really more designed to make high precision measurements over larger areas. And as the graphic shows, we have a healthy amount of both instruments available in our toolbox currently. Next slide, please. Just to give a bit of an overview of how these technologies work. So they all utilize a form of remote sensing that we would describe as passive remote sensing, meaning that these satellites rely on sunlight reflected off of Earth's surface to make their measurements. They don't have their own sort of laser-based or not producing their own light source. They're relying on sunlight. And as this happens, as the sunlight is passing through the atmosphere and reflecting off the surface, it's interacting with molecules in the atmosphere. Methane is one of those minor concentrations, but very important chemical species that is interacting with light in certain ways, and specifically light wavelengths in the shortwave infrared part of the spectrum interact with methane molecules in a unique way and creating this, what we would call a spectral fingerprint. And because these satellites are equipped with instruments called spectrometers on each satellite, they are detecting this unique absorption pattern. And it is from that pattern that we're able to estimate methane concentrations in the atmosphere below and derive emissions rates for specific sources. The example in the image on the right here comes right out of the report, so you can hopefully check out that on the link. It's a really, I think, visually striking example of a real plume captured by the Carbon Mapper satellite over the Permian Basin, and you're seeing those really high concentrations of methane in the reddish orangish color, and it diffuses sort of across the screen into the lower concentration areas in blue and purple. Next slide, please. So for those who are really interested in diving into some of the technical features and differences from one satellite to another, I encourage you all to visit again the report. This table I pulled right from there. We sort of tabulated a lot of the different satellite instruments currently in orbit and offer sort of a typology and tabulate their key technical specifications. Just want to leave you with a couple thoughts of some of the what I consider some of the key features that differentiate different satellites and help us thinking about which are appropriate for which use cases. Some of those specifications being the spatial coverage and resolution. So thinking about how much of Earth's area is able to be imaged, and then what the resolution or what the individual pixel size is. So kind of how zoomed in of a picture are we getting on the ground. Another characteristic would be the temporal coverage, or this aspect of time, thinking about how frequently a satellite can return to the same spot on Earth. And this becomes really important when we think about intermittent methane sources. So if methane plumes or their events are coming and going, it's really useful to have higher frequency measurements and give us a higher chance of actually making an observation of that leak. And then finally, a third important characteristic is the sensitivity or detection threshold of satellites. So what is the smallest leak that any given instrument can reliably detect? knowing that this is going to vary with different environmental conditions such as wind speed or sort of the background surface conditions. Is it observing in the desert or over a forested area? These are things that are all going to affect these instruments, the technology's ability to do their job. But again, if you're interested, I encourage you to read all about these in our report. And I will hand it back to you, Ted, to give it to our next panelist.
Great. Thanks so much, Fran. And I hope you don't mind. I would love to just ask you a quick follow-up question on that last point, which is
Sure.
about the appropriateness of the different technologies. And you mentioned leaks, and you showed an image of the Permian Basin. Can you just talk a little bit about the use of technologies regarding the different primary sources of methane emissions, which we know are primarily oil and gas, agriculture, and waste, and sort of how they fit with those different sectors, or do they focus primarily on one?
Yeah, that's a great point. So I think a good place to start would be thinking about sort of what I would call a sort of large area source. And that lines up with, if you think 2 slides back to that area flux mapper, so satellites that fall into that category. So I'm thinking rice paddies or, numerous thousands of cows spread over a large agricultural area. That's something we would describe as more of an area source. And there are these little diffuse amounts of methane that are kind of seeping out at all times. And that's when we would really turn to an area imager or something with a larger spatial footprint to really capture that well. By contrast, if we're thinking about a really pinpoint specific leak, let's say that there's a valve issue on a piece of oil and gas infrastructure, or maybe an unlit flare, for example, in the Permian Basin, that very well could have been the source we were looking at a couple slides or in the previous slide. That is really where we need more of a pinpoint point source imaging instrument that can give us higher resolution, and it is really designed to kind of hone in on those specific sources.
Mm-hmm. Got it. So the two technologies and approaches combined really do get at many of the different types of sources that we see in the field.
Totally, yeah. And there's even some great examples of different instrument types working together. So maybe a coarse imager kind of gets an initial look at something, and then more of a pinpoint instrument is able to follow up and get a more detailed look at a source. So they really do complement each other in good ways.
Great. Thank you for fleshing that out a little bit. With Fran's intro to the technology, we're now going to hand it over to my CLEE colleagues, Shivani Shukla and Gil Damon, who are going to give a bit more of an overview of the report sort of structure and findings, and a bit of the state of play in the policy realm. So I think Shivani, please take it over.
Thanks, Ted, and the previous panelists. If we could just go to the next slide, I'm gonna give a very quick kind of overview of what you've kind of already heard in this. That's all the ongoings in the satellite and methane world. Something unseen before, except through handheld devices, can now be spotted from space using all of these kind of different emergent technologies. And it's all very exciting, especially in its use cases for policymakers in direct mitigation. And as you can kind of see through Fran's slides and such, there's a lot of work ongoing behind the scenes. So some of the earlier capabilities for methane detection were already kind of on board, various previous satellites and such, but they were mostly kind of mixed use. For instance, NASA's Emmett instrument aboard the International Space Station was primarily sent up for dust measurements, though it could also detect methane. So we can see some of that data streams coming through more and more. And then as we're kind of seeing this expansion of a methane satellite constellation go up right in front of our eyes. So last July, the Carbon Mapper Coalition sent up their first satellite, Tanager-1, and that was a successful launch. It has started kind of beaming down a lot of methane data. Over the previous months, we have engaged with a lot of policymakers directly in expanding kind of the coalition's work and sending the data on into the hands of people who can do something about methane directly. So we'll probably link the data portal for Carbon Mapper at some point, and you can explore for yourself. That's just one of many examples of data portals and databases that are increasingly in your hands. So the coalition will also be launching a few more satellites over the coming years, hopefully successfully. As Cara mentioned in the introduction, there's always a slight risk with the launches and management of the satellites, but I bet the technology there will also improve as we send up more of these. One of the benefits of satellites, one amongst many, is that it'll supplement bottom-up estimates and observation data through kind of various kinds of reconciliation efforts. Most of them are mathematical models. We at CLEE are not particularly mathematicians, but can tell you who's working on that very important bit of the puzzle. And yeah, more of that to be seen through various public data portals again. As Cara mentioned also in the introductions, the satellites do come with certain kind of detection thresholds. They can only detect methane above a certain kind of intensity and such. There are also certain other limitations of satellite detecting methane. For instance, there could be a persistent cloud cover or the terrestrial barriers, including kind of rough terrain and such. So just being mindful of certain limitations that come with satellites, but overall a great emerging technology towards methane mitigation. Excuse me. Could we go to the next slide, please? So the intention behind this report came from a lot of what Cara mentioned, conversations with various policymakers and other stakeholders who are very curious about all the methane data, but probably kind of lack the exact understanding of what exactly the satellite is doing in terms of detecting methane, and then also information of where to find the data or the exact verbiage of the satellite work. So we have tried to fill these gaps through these reports. Hopefully, as you go through, you kind of go through sections that walk you through capabilities of various satellites, some of which Fran mentioned, and then also lists out some publicly available satellite methane data sources. These are all evolving as we go. So maybe right now you're seeing kind of a snapshot of the methane data as it stands, and in the coming months, it's increasingly being kind of expanded. So be on the lookout for improved data coming from all these sources. We've also tried to walk people through some of the initial use cases for these satellite methane detections, such as identifying any major super emitter events, kind of more point sources that are persistent or intermittent. All of this data will hopefully be coming through from the satellite world. We've also kind of chatted with the Californian Air Resources Board's satellite methane program administrators who are trying to use a lot of the satellite data to contact exact facilities and point sources of a lot of these emissions and getting them to mitigate the methane directly in various ways. This includes facilities such as landfills, oil and gas operators, and such. And on an international scale, AMIO's Marsh program, which I'm forgetting the full name for, but it's kind of an alert system set up for various point sources across the world, where you just kind of call up the facility, ask them what's happening with a certain detected plume, and getting them to abate that. So a super useful kind of use case for satellite data. Some of this data is also meant to supplement methane inventories and intensity standards, such as what we're seeing in Colorado. All of this is kind of evolving work, so very much kind of policy in action as we're going. Some of this data can also be used to assess policy and regulatory interventions, for instance, comparing a before and after of any given regulation or policy, comparing if a certain government has kind of put in place a certain mitigation strategy, seeing how that has impacted emissions. And one of the kind of bigger benefits of being able to see these plumes from space is a more refined set of calculations of emissions variability across time, location, source activity. So just getting a more kind of broader range of data. And I'm gonna have my colleague Gil walk us through some of these applications for our coalition. Gil?
Yeah, thank you, Shivani. Yeah, as Shivani mentioned, a lot of the impetus for this was working with governments, working with policymakers, designing a document, a resource that could help them begin to use this absolutely revolutionary data that we now have to really drive down emissions. And we at CLEE here at Berkeley, we helped lead a coalition called the Subnational Methane Action Coalition, or SMAC. And SMAC includes states and provinces from around the world, from Brazil, from Nigeria, from Spain, from Germany. In the United States, we have California, Colorado, and Maryland. And so we've got more than 20 states and provinces representing over 200 million people working together on methane. And this data has totally changed the game for us. It is something where now we can talk to a jurisdiction, we can show a policymaker on a map very quickly, here's a landfill right around the corner from maybe your government office, or from maybe your capital city. Here's an oil and gas facility that is leaking methane that maybe you weren't aware of, maybe that facility wasn't aware of. And so what this technology does is it does take an invisible pollutant and it makes it visible. And it's a really extraordinarily powerful thing. And what we've seen is governments are responding to it. Governments are excited about it. They want to work with this data and they want to figure out how to use it for good. And so that's something that I think we're going to hand it over to JP in just a moment. And JP's got an example from a government that happens to be a member of our coalition, Chubut. But Ted, I'll hand it back to you, and I think then over to JP.
Yeah, great. Thanks, guys. And I really want to follow up on that last point with something that we're seeing in the Q&A as well on use cases and enforcement. But first, our final panelist here, JP, is going to talk a bit about a specific example of the use case. So I'll hand it over to JP to go to our last slide.
Hello, everyone. Thank you for being here. I'm super excited of being here as well. We're very happy. This joint project with Berkeley and UCLA has been fantastic. One of our goals is to determine whether these technologies can help jurisdictions enhance their methane regulation, or if it is now possible to develop new ways of regulating methane, especially in developing countries. So this is new technology, but we haven't really think thoroughly on how to incorporate these technologies into regulations. Maybe some very rich countries can do it, and very rich jurisdictions can do it, but can these technologies help developing world jurisdictions to enhance their regulations? This is a question that motivates us. And the work we're presenting here is part of that effort. So we want to help jurisdictions to understand these technologies and hopefully find ways of making satellites a useful tool for enacting new regulation or improve the current ones. As you can see in the slides, I just put an example that we've been thinking about. We're in connection with the Chubut authorities. I see there's a couple of Argentina people in our audience, so they may know better than we do. But in general, methane regulations are relatively new in Latin America. A couple of years ago, there were only 2 regulations. In Mexico and Colombia with different luck. Some of those regulations were too ambitious and the other one kind of worked, but it's still a new thing here in Latin America. I'm now in Santiago, so for those of you that are in the Northern Hemisphere, I envy you with the hot weather. I'm very cold here. But the thing is, in 2022 in Argentina, Senator Gladys Gonzalez presented a bill to enact methane regulations, which, given the political situation and other factors, it died in the Argentinian Congress. It's now being revived by a couple of senators. But then the province of Chubut took this bill and they enact their own regulation based upon this bill. So Chubut became one of the first subnational jurisdictions in the hemisphere to regulate methane. And now other provinces, such as notably Neuquén, home of the largest oil facility in Argentina, are now starting to develop their own regulations, which is a great news. But the thing is, why is this valuable for us? Why it matters in terms of satellites, and why I'm taking this time to explain these jurisdictions is because, like many other jurisdictions in Latin America and the world, they have Chubut and the other ones have limited financial and technical resources. So the big question is, can jurisdictions like this benefit from the latest methane technologies in a way that is both effective and affordable? So that's the question we're motivating, and that's the question we want to answer. And this work, what we aim to do is that this work can be read and understood by different countries and jurisdictions, so they can think, oh, really, maybe these technologies can now be useful here in a way that we haven't thought it was possible. Because as Cara said, another one said, like, methane monitoring was very challenging, and it still is. And satellites have lots of limitations as well. So understanding possibilities and limitations may allow us to dream about new ways of monitoring methane and ultimately control and mitigate methane emissions.
Great. Thank you, JP. Fantastic way to conclude our presentations here. So I think if we can bring the whole group in and we can conclude the slideshow, we'll now shift to a Q&A and open discussion with all of our panelists. We've got some excellent questions from the audience, which I will share in a minute, but I would love to exercise my prerogative and ask the first question, which is, there's been a huge amount of information here on the technology, on the different use cases by governments. And one thing I want to ask this group, I think everybody probably has a response to it, is what's the role of this technology in increasing public awareness? There's some pretty incredible visuals. It's pretty incredible technology. It's also still a fairly obscure topic and pollutant. So I'm curious, what are you guys' thoughts on how this can be used to increase public awareness? And in particular, are there anything to do with co-pollutants or other measures that might be sort of, of interest there? And I'll open it to the full group. Go for it.
Well, I'm happy to jump in. Thanks, Ted. So it turns out that methane, as you mentioned, often co-occurs with, so methane itself doesn't have direct public health implications, but it often co-occurs with other pollutants that are really harmful to human health. And so one of the most exciting things about these new streams of data from my perspective, especially the ones that appear on free and publicly available data portals, is that they can inform communities often for the very first time about real risks that they're facing from methane co-pollutants, maybe from a landfill around the corner or from other, local industrial facilities that communities might have suspected for quite a long time were making them sick, but didn't really have access to data about, what emissions were coming from the facilities and when and in what amounts. That can really empower communities to organize themselves to work to reduce risks. I find it exciting and frankly democratizing for communities to have access to this data. So it's one of the things that I'm most excited about personally. I'll let others chime in too.
Yes, I completely agree with Cara, and but also this should kind of worry governments as well, because there will be a time or a moment where people have information and governments will not have the tools to address those concerns. So if regulation is not at the same level as technology, we may end up having a problem of spotting something in the ground, but not having any regulatory or legal tools to address those issues.
Yeah, I would just add that it adds to the argument to deal with this stuff, right? So methane is an extraordinarily powerful greenhouse gas. It's a product that can be captured and sold. It's the main constituent in natural gas. And it does co-occur with all these nasty co-pollutants. And so, pick your argument. There are very strong cases to be made for dealing with this gas. And when you can go, as any member of the public now can, and I encourage everyone to do it, I think it's data.carbonmapper.org. And you can take a look, and you can look, in your state and your county and your town, and see, you might find a plume, you might find a landfill. And just because that there's something there doesn't mean it's being mismanaged. But in a lot of cases, we're finding that there are plumes that have been allowed to occur for a long time and have been mismanaged. And so it does encourage a lot of transparency and accountability, and it helps make the case for dealing with this really, really problematic gas that we have.
So that ties to a question that we have in the chat, and it links to JP what you were describing in your final remarks just a few minutes ago, which is the use of this imagery, the use of this data to enforce and to enforce regulations or laws that are on the books. Of course, JP, as you said, that's premised on there being regulations and laws on the books that actually limit or restrict flaring or restrict plumes. So I'm curious if there are examples that this group can share of regulatory action that has been taken based on satellite imagery, or has been threatened or proposed as sort of a potential case study, and maybe in addition to sort of the initiating exercise that you talked about, JP.
I'll perhaps start with a program that almost took wing in the previous administration. So the federal government of the U.S. Through the Environmental Protection Agency had set up a program where if there's a detection of a super emitter, so point source kind of emitting above a certain threshold, they could be identified and then kind of pinged to mitigate that certain kind of degree of emissions, otherwise face penalties and fines. That certain program was pulled back in the current administration. However, it kind of did lay kind of a groundwork and framework for how these kinds of technologies can be incorporated into a lot of this mitigation activity.
And I can add to that if you don't mind, Ted. I do think folks might also be interested in the example that's being set by Colorado, which is, I think I heard, one of the SMAC jurisdictions, and so one that folks on this webinar may already be very familiar with. But to my mind, the state of Colorado in the United States is doing some of the most interesting work thinking about how to employ this new data from satellites in a regulatory context. Some of you may know Colorado has in place already a methane emissions intensity standard for the oil and gas sector. It's thinking through, and is further along than almost any jurisdiction I know. It's thinking through how to employ satellite data to help implement and enforce that emissions intensity standard in the oil and gas context. Satellites are still pretty new, so I would characterize Colorado's efforts on this score as still nascent, but moving forward pretty quickly. So it's one of the things we're looking at with a lot of excitement to see where it heads next.
Yeah, absolutely. And always important to note that in the US, there are non-California partners in a lot of this work, and Colorado has been leading in a lot of ways. We're getting a few questions, and it came up earlier on methane sat and the unfortunate events of the last few weeks. I'm curious, maybe, Fran, do you have any sort of additional detail that you might be willing to share on just sort of what happened, what we know about the event, and what can still be gleaned from that pilot?
Sure. Unfortunately, I don't have any insider knowledge of anything more than that's what's been put out by Environmental Defense Fund as far as what happened and the reason for the power system loss and the loss of communication with the satellite. But again, it's just really disappointing, and I can't imagine being one of the folks who had worked so hard for more probably a decade building that system, and it was very promising for all of the data that it was going to be collecting for many, many years. I do hope that we can think about what are the positives that we can take from it, and I think there are several. One being that it was up and monitoring for a year, and from what I can tell from the statements and from talking with folks over there, they're doing everything they can to glean as much information about the data that was collected. And a year's worth of data from a fantastic instrument is not nothing, so we shouldn't totally discount that. And I'm sure there are on the technology side. I mean, it was more than a proof of concept as far as what they were able to build and launch. So I'm not able to say if there will be, a next methane sat, but I'm sure that the things that were learned from creating that instrument won't go to waste. And just looking forward to what we are able to learn from the short time that it was available.
And Fran, maybe sort of stepping back a level, that leads to a question that I was wanting to ask this group, which is, we were in a situation where we kind of, I guess there were two most prominent operating examples, and to be reduced by one tragic event is really distressing. But there's a future scenario, I imagine, where there are not two, there are an appropriate number collecting all the necessary data at the appropriate times to serve the need that we're all describing from a policymaking and regulatory perspective. Is there any sense in this community of where do we want to be in a decade, in a couple of decades, in terms of global monitoring of this pollutant? Obviously, it's more than one.
Sure. And I mean, we see this idea of a constellation of instruments coming up again and again. And I personally think that is a lot, hopefully the future of this, and hopefully not too distant of a future where we have, a whole team. I kind of think of them as a team of instruments working together, getting really frequent, high precision measurements, over as much of the world as we can. So, and again, I haven't worked at NASA. I'm not a total space guru, but losses in space do happen. This is a really tragic event, but I think that it's just part of the risk of working in this industry. So I'm really hoping that we can acknowledge the event and move on, but just thinking about what's to come. And I really do think that there's a lot more of exciting expansion of this technology type and the role for satellites in general that we still have to look forward to.
Yeah, if I may add very briefly, in a lot of our conversations with members of the Methane Coalition, we do hear kind of ideas and excitement about individual space agencies launching or kind of planning to launch some of their own programs. And obviously, a lot of this kind of information is discreet and kind of behind closed doors. But just the mention of them, for instance, from South Korea and Japan and stuff have been interesting add-ons to conversation. So I can only see this, as Fran mentioned, this kind of team of satellites growing.
And there's also an urgent need for more data. Like, we need more data, and the data have proven to be really interesting, reliable, and important. However, there will be a challenge about, like, how do we receive and how this information is processed, because there's if we have so many satellites, we may possibly have so many ways of showing the data. So we might need to find a way of, like, uniforming the way in which we communicate the data so that everyone everywhere in the world can use it effectively.
Mm-hmm. Sounds like you almost need a subnational coalition around the world to help gather and manage this stuff, is kind of what I'm getting from that. That might work, yeah. So there's to be taking a step back from sort of the satellites themselves and a little bit more on the use, which we've touched on. We've got a question from the audience about what's needed to actually incentivize more governments to obtain and use the data. Technology's there. You guys do a great job of explaining what it can be used for, and we know some jurisdictions have or are developing regulatory approaches, but are there other incentives that need to be provided or at least demonstrated to make this technology and this data usable? I'm thinking maybe in the oil and gas sector in particular.
I can start on this one and name a few things I think would be helpful. Some of which are things that I know our colleagues and friends at Berkeley and we at UCLA are trying our best to help with. I think one thing that's necessary, and again, this was in part the impetus for this project, is better information sharing with and among jurisdictions about what this data is, what its strengths are, frankly, what its limitations are, and how to interpret it from a legal and regulatory perspective. And so that's part of, what I think many of us are hoping to help with. I think another thing local jurisdictions need, and this goes back to JP's point about the variety of ways that folks can now access this data. I think accessing the data, understanding how data has been processed and what the processing means from a regulatory and legal law and policy perspective is really important. And I think the ecosystem of data portals is still very much developing right now. And so I think it needs to mature a little bit. That ecosystem of data portals and data sharing has to mature a bit before local jurisdictions and other jurisdictions really feel comfortable relying on these portals and this data sustainably over time to really build out policy. And then I think the third thing I'll say is actually obvious enough that maybe I shouldn't mention it, but I think jurisdictions need support, both information support and, frankly, monetary support to help develop new ways to incorporate this data into their regulatory structures. They're overworked, they're underfunded, just like so many of us. And so I think the more support they can get from institutions like ours and funders and others about how to really put this data into action, the better.
Mm-hmm. Anybody want to follow on that point? There's also sort of the question that's popped up in the chat, which I'm curious about, which is Gil, you mentioned, I believe it was Gil mentioned capture and use. And I think we, in the oil and gas context, we see an area where we know, and there's been for decades, understanding of how much value in that supply chain is lost via leaks and can be detected as a climate problem, but is also just an economic problem. And yet industry is not uniformly jumping at solutions to address all of their leaks. And so I'm curious, how does this data help bridge that gap in a, what can be viewed as a sort of a revenue positive way?
Well, one of the things we've seen in the oil and gas industry, especially, is that when the data is presented, folks tend to be interested quite a bit at the time. And so a lot of times what you'll find is, there will be a leaky pipe and a valve fitting that needs to be addressed, and folks just aren't aware of it. It's an invisible gas. And so you do have an industry that is venting an enormous amount of its product into the atmosphere. It's also true that that product is cheap to them. And so, there is a question as to, well, why aren't they doing more about it? Well, it's because you do need incentives to come behind it, and you may need regulations to come behind some of the technology and kind of prompt folks to move ahead. But, it is staggering the number of times that it's just a matter of knowing and dealing with it, sending someone out to fix a piece of infrastructure. So you can make money at it in the oil and gas industry. Landfills, a lot of times, it's similar where you can capture methane. That is a product that is also valuable if it comes out of a landfill. And even looking at the agricultural industry, this is not so much of a satellite case because often those sources are too diffuse to spot from space. But if you have a cow and you give that cow a feed additive, or you give that cow a vaccine, or in a lot of cases, you just, treat the cow in a way that keeps it cool and well fed, you're going to produce more milk and you're going to produce more meat, and you're also going to abate methane most of the time. And so that can be true also when it comes to rice. It's across the board really an issue where you get a huge bang for your buck, and a lot of times you're doing it at a relatively low cost or no cost. And so there is an open question as to how we get incentives and regulations to sort of come behind what we've got here. But these are not major tweaks in a lot of cases that need to happen in order to start to tackle methane.
Mm-hmm.
I can just chime in briefly and double tap on the use of satellites for landfill measurements that Gil mentioned, and also there was a question in the chat, because I do think that oil and gas get a lot of the attention when we talk about satellites, but I do think that the waste sector is another really strong use case for these technologies, and in some cases seeing where landfill gas capture projects, which is a sort of a viable capture and use to the capture and use question that came up, because you're able to basically like hone in on a really concentrated source. We can't really like just take a ton of energy to make anything useful about from the really, really diffuse methane that's in the air and in the atmosphere. That's just way too dilute to make it really profitable. But since you have a landfill in this really high concentrated stream, it is an opportunity for capture and use. But sometimes these systems unknowingly are malfunctioning, or there's a leak, or something's going wrong. And there are numerous use cases of being able to use sort of the point source imaging satellites to sort of diagnose that and make repeat follow-up measurements to make sure any corrective action has had the intended repair.
Mm-hmm. Yeah, that's very helpful. All right, so we've heard a couple of examples. Cara, you talked about leadership in Colorado. Obviously, we know that California is doing some of this, and you know, Shivani, you mentioned some international interest in developing or supporting new satellites. JP, you gave one example from Argentina. I'm curious if the group can just share some of the most interesting examples of international leadership in this space that our audience might be, you know, sort of interested or surprised to hear about jurisdictions, subnational jurisdictions that are leading this work on different on either individual sectors or via the satellite technology.
Yeah, I think I might give us a head start, and as more examples come to mind, probably we can share them out. One of the most interesting conversations that we've had via kind of SMAC is with the state of, or rather the province of Gyeonggi in South Korea, where they're very interested in kind of the use of all of the satellite data, and then they're keen to build out a program where they have their own constellation either, or they're partnering with international entities, and then getting kind of their own data and processing underway. A lot of this, again, information is nascent, developing. Everyone's kind of eyeing each other's work to see what they might glean and use towards their own. So again, a very kind of emerging use case. I would mention also from a chat with the IMEA folks and the Mars folks. A lot of this work comes down to kind of international diplomacy, where there might be kind of detections of huge methane plumes from a given source, given country, having more so than others. But getting in touch with the officials in that country, getting them to kind of be on board with a lot of this detections is another kind of matter in itself. So all of those sorts of conversations are emerging, but also building on each other. And then hopefully that leads to a point that JP mentioned, kind of a standard approach to a lot of this work.
I can just jump on top of that and say a couple more things related to my earlier point about the need for support, information sharing, and funding in this space. When I think about global leadership on methane emission control and satellites, I think, of course, both about the jurisdictions that we've mentioned so far, but also about some of the leaders in the funding space and in the coordination space. And I put SMAC like right at the top. So hats off to my Berkeley colleagues for the work that you all have done to create the SMAC coalition and use it as a platform for information sharing across jurisdictions. I think that's incredibly important. I also want to give a shout out to the Global Methane Hub, which is a big funder in the space, and to other funders who have really prioritized helping to make global methane pledges a reality, because I think that work is tremendously important.
And Gil, anything from the sort of SMAC big picture perspective that you want to add, or sort of perspective members
Yeah.
that are interesting?
Well, I mean, what a lot of this is like, a lot of it is just demystifying the subject, right? This is just an unfamiliar subject. We haven't talked about methane that much in the public domain until fairly recently. And so we have a lot of curiosity, and we have a lot of jurisdictions who really just want to figure out what's going on with this, why is it bad, and how do we deal with it, and how do we show leadership in a lot of cases. And so, the way we've structured our coalition, SMAC, is that we don't answer every question. We can't be the experts in everything, but we bring in folks from across the space, from across, different sectoral experts on methane, folks who are experts in satellites and who are experts in other monitoring technologies, folks who have regional expertise about how to, navigate, how to exercise diplomacy in parts of the world where we're interested in operating or recruiting. And so it's become a network where if a jurisdiction comes to us with a question about something, it can be pretty obscure at this point. We probably can match them with someone in our SMAC network who's going to be able to help. And so, that's something where what we've seen is it's really heartening, because when that resource exists, when there are places for folks to go with these questions, and to go with their enthusiasm for the subject, then we can do a lot. And I think that, when those things are presented, when the resources are there, governments are really excited to work on this stuff. And I think that, it's totally independent of, other political wins. It's really something that kind of exists on its own, and can just do an enormous amount of good.
Great. Thank you, Gil. Well, that's a pretty good segue to my final question. We've got just a few minutes here, and I want to ask each of you the same question. We'll start, I think, with Cara. So obviously, we're in a big moment of climate policy whiplash here in the U.S. and I think globally, in many different ways. And I think it's particularly strong in the methane space, which accelerated so rapidly under the prior administration and had so many successes. And now we're seeing some serious rollbacks of federal policy initiatives, as well as the loss of one of the main satellite technologies that you guys have been talking about. So I'm curious, how do you see this work and this satellite work in particular fitting in this moment and helping to address it? Where does the satellite and methane tracking approach fit in sort of the context of the broader climate policy challenge we're seeking?
Thanks, Ted. I don't mind confessing that I find the rollback of US federal efforts on methane to be somewhat heartbreaking. But I also take hope and inspiration from the many jurisdictions, international, transnational partnerships that are pushing forward. And I think of satellites as being part of or providing really important tools to help advance that momentum. So from my perspective, the current policy context means it is more important than ever to make progress in the places where we can and with the partners with whom we can. And this is one of those places from my perspective, which is why I'm really excited to be working on this. And again, as I mentioned at the top, think of it as among the most important things we're probably doing at the moment.
Great. Thank you, Cara. JP, any thoughts you'd like to add to that?
I was thinking on your previous question, and one of the if the question was asked 2 years ago, I would say that the indisputable leader of methane action control regulation, etc., was the U.S. We were at the Dubai COP, and like U.S. was really leading the charge on methane. So things have changed now, and this satellite may help other jurisdictions to take control as well, to take the lead as well. I think the Latin American example is very encouraging right now. Many countries are working on methane regulations, and I do think that that satellites may be able to help creating better regulations and easier ways and affordable ways of spotting methane leaks. So I think this is good news.
Great. Thanks, JP. Shivani, over to you. Final thoughts on how this technology can meet the moment.
Yeah, absolutely. A lot of this has already kind of been captured over the webinar, but the next steps I would see emerging from a lot of the satellite data is kind of building out pilot projects, for instance, like just identifying huge plumes that are occurring, or even kind of mediocre plumes that are occurring any which way, like picking out a plume and then leading the process from the detection to its actual mitigation, and then showing kind of, the exact emission that was abated throughout this process. Building up more and more case studies like this direct mitigation might encourage kind of more jurisdictions, more communities, more stakeholders to see how useful a lot of this data can be. And even if it's not down to kind of the exact decimal point, you do get a pretty good sense of how much emissions could be mitigated.
Great. Thank you, Shivani. Fran, final thought?
Sure, and maybe I can offer a thought from the perspective where I sit now as a grad student at Stanford, and I study this technology as part of my research. And I do think that while, politically and socially we're in this sort of trough of hopefully be, eventually again a cresting wave of excitement around methane, but as far as the type of studies that we do here to examine these technologies and how well they work under different testing environments, we still see so much enthusiasm and momentum from different partners and operators. I mean, we're actively testing 12 different satellites launched by various groups, agencies, commercial partners, nonprofit partners all around the world, and there are dozens of groups who are honing their analysis skills, getting better and better at modeling these plumes, and better and better, more accurate, more precise at quantifying individual rate sources. So I still think that there's going to be a lot of learning, scientific learning going on. Maybe a little bit more quietly than it was before, and then hopefully, if we get the opportunity again, we'll be able to apply it to a number of great policy applications in a couple of years. So hopefully more to come.
Awesome. Thanks, Fran. And Gil, final word.
Yeah, I'll just say, we like to describe methane as the climate emergency brake, and that's what it is. It's 84 times more powerful than CO2. It's something that we can control today with current technology. And now we have satellites that can help us do that. And so it's all evolving. It will all change, but we have what we need to do this work now, and governments are doing it. And it's our goal to make sure that more and more get on board and become part of this momentum. But we're doing our best to try and save the world, and it's nothing smaller than that. So yeah, that's what I got.
All right. Well, thank you all for an excellent conclusion there. That was actually very well done. Thank you everyone for joining us today, and thanks to Cara, Fran, Gil, JP, and Shivani for their excellent work in this report and today's webinar. Thank you as well to our administrator, Ellie, for putting together an excellent event and hosting this really, really well. And thanks to our Lunch and Learn partners, Wilson Sonsini, Oric, and Hanson Bridget, for helping us put on this series and today's conversation. Thanks everyone for joining us, and have a great rest of your day.
Thanks, Ted, for moderating.
Yep.
All
Bye,
right.
guys.